So it's the electrical forces, in fact, and the magnetic forces, in fact, that we have to accept as the base reality in which we're going to explain all the other things. So again, it turns out it's hard to understand. You have to do a lot of imagining. That the real world has as its base a force which acts at a long distance. That we haven't got much experience with that force. We have peculiar phenomena here and there, but ordinarily we don't have much experience with that force, is simply because that's what requires explanation. That's what requires imagination. The long-distance force we have no other picture for. What happens is that the electrons, which are a part of an atom, they're pushed by the motion of the copper wires. And it's wonderful to think that you push a few here, and they get too close together, so they push the others because they repel at a long distance. So it's not just like water, which repels at a short distance, but it's a wonderful fluid which repels at a long distance, and the effects therefore can go very quickly through the wire. If there's a little concentration, it goes zing through the wire all over the city at once. And you can use that stuff to make signals. You can push a few electrons here and there by talking in a telephone. At the other end of the line, a long line of copper across the city, the electrons respond because of this very rapid interactions over these long distances to what you're saying in this room. And if they've discovered experimentally the existence of these long forces and these rapid motion actions and so forth, was a tremendous thing for human beings. I think that the discovery of electricity and magnetism and the electromagnetic effects, which were finally worked out, the full equations for everything was worked out by Maxwell in 1873, is probably the most fundamental transformation of the most remarkable thing in history, the biggest change in history.